Good morning, everyone. So let's do this warm up here. If you are watching the video later on, what I'd like you to do is pause it, go through these questions. These questions are actually questions from the quiz, and we'll talk more about that. But these are ones that we struggled on as a group. So I wanted to make sure we went back and went through those. So let's look at the first piece. We are given the ratio of secant. Secant of some angle is equal to the square root of 13 over 3. And then we want to use that ratio to figure out what is cotangent. Now, I set up some things here. I set up SOHCAHTOA just to help me out. And this is doing way too much work. But the thing we need to know from this is, what is the ratio of secant? Well, secant is the reciprocal of cosine. So secant of some angle, in this case they call it A, is equal to the ratio of hypotenuse over adjacent. So when I'm reading this, that means my hypotenuse is 13 and the adjacent is 3. So if you would like, you can set up a picture. We're going to be doing this a lot today. So here's angle A. We can use A or we can use theta, but I know the adjacent side is 3, and I know the hypotenuse is the square root of 13. What I'm looking for is I'm looking to use this information to find cotangent. Well, cotangent is the reciprocal of tangent. And if tangent is opposite over adjacent, that's the TOA, then cotangent is adjacent over opposite. Well, I know what the adjacent is. Now I just have to find the opposite. So really, this is just a Pythagorean theorem problem in disguise. We know that this is a 90-degree angle. So to figure out the missing opposite side, I'm going to take the hypotenuse squared has to equal 3 squared plus, I'll use O for opposite. Maybe I'll use OPP for opposite. So then what do we get? Square root of 13 squared is 13. 3 squared is 9. If I subtract, we end up getting 4 equals the opposite side squared. And if I take the square root, then I get the opposite side being 2. Okay, so now all I have to do then is set up the ratio that they're asking me for. What is cotangent? Cotangent is adjacent over opposite, 3 over 2, and we're done. All right, so there's the first one. All right, the second one, there's multiple ways that you can do this problem. I personally like to draw a separate 30, 60, 90 triangle. And then we know that if it's a 30, 60, 90 triangle, it has those special lengths. Across from the 30 is 1, across from the 90 is 2, and across from the 60 is square root 3. And those will always be the case for a 30, 60, 90 triangle. You really need to have that memorized. All right? Now, what are we going to compare? Well, I'm going to compare the side length across from the 30, which is x, compared to the side length across from this 30, which is 1. So the ratio of x over 1 has to equal the ratio of 6 is across from the 60, and square root of 3 is across from the 60. And then it's just a quick cross multiply. So 6 times 1 is 6 equals square root of 3, square root of 3 times x. And then we just have to get x by itself. So I'm going to divide both sides by 3, square root of 3. But notice I get this square root of 3 on bottom, and we didn't like that, so we had to rationalize the denominator. So I'm going to multiply the top and bottom by the square root of 3. And that turns into 6 square roots of 3 up top over the square root of 3 times the square root of 3 is the square root of 9. But the square root of 9 is 3. and then 6 divided by 3 is 2. All right. And then the last one seemed to give us problems on the quiz as well. For this one, you had to know that we have the radius is 7, so that's r. The angle measured is in radians. Okay, we're okay with that. Now, we're looking for arc length. So arc length is s times r times theta. But if theta was given in degrees, then we would have to convert that into radians. And if you got that style of a question on the quiz and you did not convert it, that's probably where you went wrong. All right, so we're just going to take the radius times pi over 3. Remember, this radius is like 7 over 1. And my rule for multiplying fractions is you multiply straight across. And since 7 over 3 doesn't reduce, there is my arc length. All right, now what I noticed is if you wrote it like this, and some students did, Delta Math is pretty picky. This is acceptable, but I don't know if Delta Math accepted it. So we just want to be careful on that. It's kind of a notation thing. If you put it as 7 pi in parentheses, then divided by 3, that's okay. But I think if you pull the 7/3 and then the pi out, they should accept it because mathematically that's accurate. I'm just not sure if it is. Okay. Here was another question we had on the quiz that it got a lot of students. So just really quick, the 3 warm-up problems you just did were based on questions from this quiz that was due on Sunday. 16 of us did not take this quiz. And I'm going to tell you what we're going to do with you 16 people, so you'll be able to get credit for that quiz. And then we'll talk about remediation as well for those of us that need it. But this was an example as well. They give me the radius is 14, and then they give me theta is 92 degrees. Right? So the first thing I need to do, if I'm going to find the arc length, I want to find the length of x, is I need to take 92 degrees, and I need to convert that into radians. Right? So we're going to times it by pi over 180. Now, to be honest, I'm just going to leave it like this. Even though, yes, I could divide by 2, and I could get a reduced answer, I don't really care because when I plug it in, it's going to simplify itself out anyways. So there's my theta. And arc length is the radius, which our radius is 14, times (92) pi over 180 times theta. There's multiple ways you can reduce this. Since these are bigger numbers, what I would do is I just grab my calculator and I would do 14 times 92 up top. And then just leave pi off at the end. And then on the bottom, I get 1 times 180. Okay? And then in my calculator, I'm going to take this fraction and simplify it. I'm just going to take 1,288 divided by 180, turn it back into a fraction. Leave pi as part of my answer. And there you go. And then this would be inches because it's the length. I guess I could have called it x, but we've always used s. So hopefully that helped answer a couple of questions from the quiz. This video will be posted and these notes will be posted so you can go back and look at them. But here's what we got. I just posted, maybe 20 minutes ago, a remediation assignment in Delta Math. So what you're going to do is if you did not take the quiz, okay, if you did not take it, you need to do the remediation assignment all the way through. And there's, instead of doing the 10 problems for the quiz, they now each have 2, so you have to do 2 of each. So you got to do a little bit more work because you decided not to do it in the first place. But But for those of you that did the quiz and you want to earn points, what you can do, let's say you got number 2 wrong. All right, if you got number 2 wrong, then you have to do this section completely. And then let's say you got number 5 wrong, then you have to do both problems in section 5. And it's not numbered, so you just got to count which one. But when you check your quiz score, you go back in your original quiz, you can see which learning target you got wrong, and then you just have to do both problems in there. So let's say you got those wrong. You do 2, 4, 6, 8 of the problems, and I will change your grade back to a 10 out of 10. All right, so if you would like to take advantage of that, please do so. I would like that done by this weekend. So if you can get it done by the weekend, then I'll be able to update grades. Conferences are next week, so that's a good way to just boost your grade up a little bit. And then what I want you to do when you're done with this is you need to take a screenshot and email it to me so I know, because there isn't a spot for you to upload the remediation into Schoology. All right, so if you have questions on that, please let me know. If you want to take a quick little screenshot of this slide so you know exactly what to do, you can do that. But again, these notes will be posted. All right, so we are using some of these skills that we just took the quiz on today. And we're going to keep building your knowledge on almost all of this. We aren't going to do a lot with arc length today, but all the other things are fair game. So 4.3 day 1, we are evaluating trig functions and using angles of reference in a coordinate plane. So you don't need to write this, and the learning target is on every slide. So just title your notes 4.3 day 1. We're going to jump right into it. Okay, here's the learning target if you were writing it down before. As we saw in a couple of these problems, when we evaluate trig functions, sine, cosine, tangent, or other types of trig functions, they're reciprocals, everything was based off an angle measure. And that angle measure can be formed from a triangle, and that's our goal today. So we are first going to do a quick explanation about how do we measure angles. Okay? And we're talking about this in a coordinate plane. So when we think of a coordinate plane, that's your XY plane. And we have an initial side and we have a terminal side. Okay? The initial side, I think of the word start. Terminal, I think of the side or the term end. Right? So where do I start and where do I end? And the angle that's formed between them is usually used as theta, but it could be A, B, it could be anything. It's just a letter. So let's think of this idea of standard position. Okay? So when I talk about standard position, look at this blue angle right here. Okay? This blue angle has a start, and we will always start right here. So we'll always start kind of on the positive x value. There's a reason why I'm not showing you the whole slide yet, but so here's my initial side, and then it's going to go up, and this letter, this could be theta, it could be alpha, beta, it doesn't matter. But then here is the terminal side, right? So it's where I start and where I end. And if we go counterclockwise, right? So if I turn my angle and I go up and I end, I don't have to end here all the time, but if I do, notice I'm going in the positive direction. This would be considered roughly, if I estimate, like a positive 45 degrees, or if we converted that, that would be pi over 4 radians. So those are my angle measures, and that's what we're really going to be focusing on today. But what if I don't go counterclockwise? What if I go clockwise? What does that tell us about the angle? And hopefully this is familiar. We did talk about some of this in Algebra 2. So look at the red angle. I can call this one beta, And instead of, here's my initial side, we always have our initial side on the x-axis in the positive direction. As I open downward and I go clockwise around the circle, that's going to refer to a negative angle. Or sometimes students think clockwise means you start going down. And let's say this is beta instead of alpha. Well, this angle is probably it looks like it's about 30 degrees less than 180. So I might call this negative 150 degrees. Right? Or what would that be as a radian? We're not really fully set on this yet, but this would be negative 5 pi over 6 radians. And I'll share with you how I kind of knew what that was so quickly. But the big thing is notice the negative. The negative refers you're going clockwise. Now, what's important about this is not just where the terminal side ends up, but what's going to happen is we're going to start drawing triangles in here. And we're going to be looking at not the big angle all the time, but we're going to be looking at the small angle that's formed between the x-axis. And that's called a reference angle. Okay, so I'll give you a second to get that caught up. All right. So our first goal is just if I give you an angle measure, let's say I give you 120 degrees. That's positive, so you're going to have to go 120 degrees, and then we'll graph where that's at, and then we're going to build off of that. So a lot of kind of stepping stones here. All right. So before we get into fully graphing, we're going to introduce one term called coterminal angles. So think of that word coterminal. Co, is referring together. Terminal is referring to where the angle measure would end. So we've got coterminal angles. Those are just angles with the same initial and terminal sides in a coordinate plane, but they're different measurements. Let me just show you a quick visual. You don't really have to write this piece if you don't want to. But let's say I have an XY plane, and I have an angle that starts here. Here's my initial side, and then it goes, let's say 60 degrees. Right? So I go up, and I know that's 60 degrees, which 60 degrees is the same as pi over 3. But this is the terminal side, right? It ends here. But what if I go all the way around the circle and then right back to where I started? Right? Let me redraw that. I don't love how that showed up. So I'm going to go all the way around the circle, and then I'm going to go and end at the exact same spot. So this angle shares the same terminal side and the same terminal side and the same initial side, except for they have different measurements. because the blue angle was just 60 degrees, but this orange angle went all the way around the circle, so it went 360 degrees plus another 60. So if I add those together, 420 and 60 degrees are considered coterminal angles. So one way to express coterminal angles is if my measure is in degrees, we can add or subtract 360, and then this times by n. N is the amount of times I would go around. So what if I kept going around again? If I went around again, it would be adding another 360 degrees to this. And then if I kept going around another time and another time, every time I go around the circle, it's adding 360 degrees. Well, instead of adding 360 degrees a whole bunch of times, if I go around the circle 4 times, n would be 4. So I would take my original 60 degrees plus the 360 times 4, and that would give me the ending measurement that would be coterminal with the original 60 degrees. Okay. So we'll kind of share how that looks. Now, this is exactly the same thing. Remember, 360 degrees is the same as 2 pi. So if I wanted to think of this as $60 is the same as pi, pi over 3, how would I represent the 420? Well, we would take 360 degrees is the same as 2 pi. 60 degrees is pi over 3. The downfall with this is you have to get like denominators here before you can add them. So I would need to times this by 3. So I would have 6 pi over 3 plus 1 pi over 3, and 7 pi over 3 would be coterminal with the original pi over 3, which means 420 and 7 pi over 3, those are the same thing. Okay, so we're going to get a lot more exposure to this. I just wanted to show you what this notation meant. So let's look at a couple. Oh, I thought these were. There we go. And we want to list some coterminal angles. Now notice, there's a plus 360 and a minus 360, so I can go in different directions. And I'm going to show you a really quick way to do this in your calculator, at least with degrees. So let's take this 30-degree angle. All right? And since we're doing it degrees, we're going to take 30 and hit enter. That's going to log our answer. And then what I'm going to do is just add 360 to it. Right? And then if I hit enter, I get another add 360. So it just keeps adding 360, and I could go on forever. Right? There's an infinite amount of coterminal angles because we just keep adding 360 degrees. So I'm not going to get too crazy here, but we knew 390 was 1. If I do 30 plus 360 times 2, notice that's where n would be 2. That would tell me to go around the circle twice, plus the extra 30 degrees. What was that? That was, I already forgot. That was 750. Yeah, let's just do the last one since I did it. Oh, wrong button. What is it? 1110. And then I'm just going to put dot, 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 because this could keep on going. However, That's not all of them, right? We have more by doing 30 minus 360. So that's where I get negative 330 degrees. That would be another coterminal angle. And then I would take 360 minus 2, or I could just take this answer and subtract 360 from it. And I could do the same thing when it's 3. So I'm just going to use my calculator again to kind of not cheat, but make it easier. So what could I do? I would do 30, hit enter, and subtract 360. And then hit enter again, and you can keep going that, and you'll generate all the coterminal angles you could ever wish. Right? So we got negative 330, negative 690, and 1050. Okay. Degrees are pretty friendly, right? Because we can add and subtract 360 all day long. But when I have radians, that's where it gets a little harder. And we do want you to always try to work with radians. Some students in the past are like, well, what if I just convert it to degrees? It's not worth your time to always just think and convert things to degrees. We want to get used to radians. And the more you start doing it now, the easier things will be, especially when you get into calculus next year. All right, so let's look at some coterminal angles. Now there's a hint here. I have to add 360 or 2 pi. Right? 2 pi is the same as 360 degrees, but if I write 2 pi, just like we did up here, I need to have the same denominator before I can add these. So what I'm going to do is I'm really going to think of this not as, oops, sorry, I shouldn't have put that 3 under there. That was a 1. So what I need to do is I need to take this and I need to get it to have the same denominator. So I'm going to multiply top and bottom by 3. So now 2 pi just changes its appearance, and now it looks like 6 pi over 3, which confirm to yourself that that is still 2 pi. Well, now I can just add straight across. 2 pi plus 6 pi is 8 pi over 3. And there is a coterminal angle with the original one that's given. Now, much like we did here, I can keep adding 2 pi to it. And to be honest, since I already know what this answer is, I'm not going to just reset it up like I did here, even though I could. I would just add, watch what happens. What if I add another 6 pi over 3 to this? Well, 6 plus 8 is 14 pi over 3. That's the fast way to do it. That's another coterminal angle. And what if I add another 6 pi over 3 to this answer? Well, 6 plus 14 is 20. And we could keep going. So that's just every time we add a 2 pi or a 6 pi over 3, that's going around the circle one more time. Okay. You don't have to write this part, but let's say I wanted to do this longhand for this one. What did I do? I took my original answer, and I said, well, I have 2 pi, but 2 pi is the same as 6 pi over 3 for this case because the denominators are the same. And I added 1, 2, 3. I went 3 times around this circle. So this would be like the n value that we were talking about up above. And hopefully you can see 6 times 3 would be 18 pi over 3. And then 2 pi plus 18 pi, that's where the 20 pi over 3 came from. So there's easier ways to do this, and there's more challenging ways depending on how much work you need to show. So let's show you how to use this. Oh, by the way, I guess I didn't do this. I kind of forgot. What if I took the 2 pi over 3, our original angle, and instead of adding 6 pi over 3, what if I subtracted it? Well, 2 minus 6 is 4 pi over 3. Here is another coterminal angle to the original 2 pi over 3.
-4.
Thank you. Yep, -4. Good catch. Right? And then what if I just keep subtracting? So what if I subtracted, I took this answer and I subtracted 6 pi over 3. That would be -10 pi over 3. And again, you probably can see the patterns. The next one would be -16 pi over 3. And then we would keep going. -22 pi over 3, and so on. All right? So what we want to do then is, this is one of the, you don't have to write this. I just want to show it to you quick. I don't want to take the time to write it because, to be honest, I would do this mostly in my calculator. But what they're asking for is, here's your angle in degrees. You need to find a coterminal angle to that. And your answer, theta, notice they say your angle theta, this is your answer. Your answer has to be between 0 and 360. Well, what we need to do is just take this and keep subtracting 360 from it until we get our answer. So if I do it once, I get 460. 4 degrees are left over. That's coterminal to 824, but that is not in between here. So then I just have to subtract again. And when I do that, my answer is 104, and that fits right in between. So it's really quick, just coterminal, you're adding or subtracting 360. What if I have a negative number? If I subtract or go further down, notice my answer has to be between 0 and 360. So then I'm going to just take this -794, and we're just going to keep adding 300 to it until I get to an answer that is between 0 and 360. So notice I added 360, I got -614, and then I added 360, I got -245. You can hopefully tell the next iteration will give me the answer that I want. So theta is equal to 106. And you should confirm that 106 definitely lies between what they're asking for. All right, so it's pretty quick. All right. This next piece is very important. It's the idea of something called a reference triangle, or we can say reference angle. So please take really good notes here. A reference triangle is a triangle formed when the terminal side of an angle and the perpendicular line drop down to the x-axis. Now it depends on what quadrant we're in. So we're going to start with all 4 quadrants, and you should keep in mind how we identify which quadrants are which. Quadrant 1 is when your x and your y values are positive. So think about that. When I go over to the right and up, both x and y end up being positive. Well, if I have an angle like this, you end up with theta right here. So as you're writing this, a reference triangle is an angle formed with the terminal side, that's where we end, of an angle, and the perpendicular line that drops down. So remember, we always have the initial side right here on the x-axis. That's when we're at a 0 degree. And then in this case, we go up to be positive. Now, if I take that terminal side and drop it down, you see the triangle that's formed here? That's going to help us identify which side is opposite, adjacent, and hypotenuse, which allows us to get to SOHCAHTOA, right? And so that's our whole skill, is we're really getting this point where we're going to SOHCAHTOA right now. Okay, now, things change when you move to different quadrants, because we're all focused on this x-axis. Remember, the x-axis is the horizontal line. The vertical line is the y-axis. So what about quadrant 2? Now here's where we have to be really conscious of what we're doing. In this case, the theta is both considered my reference angle and the original angle. But in this case, the original angle is, let's say it's a positive 150 degrees. So I'd open up 150 degrees, but I need to draw that triangle in. So the triangle that's going to be drawn in is from the x-axis to the terminal side. And notice, this triangle right here is the reference triangle. Okay, now, why is that important? Because that gives us a new angle. Right? Some people call this theta prime. Some people call it alpha, beta. It doesn't matter. I might use just a different Greek letter. Let's use alpha. But what does that do? That gives me a reference angle right here. We're really focused on this new angle. We needed the original angle to tell us where the terminal side ended, but now we have a new angle, and that gives me the opposite side, the adjacent side, and the hypotenuse. And now, knowing those lengths, I can do sine, cosine, tangent, or their reciprocals. I might put a little note here. My angle symbol theta, or I should say alpha, is called the reference angle. So that was quadrant 1. This was quadrant 2. Notice the x value is negative, so my adjacent length would be negative, but the opposite would be positive if I ended up in this quadrant. So I go over to the left and up. That's quadrant 2. Well, what if I'm in quadrant 3? So what if I go over to the left and negative? What that does is that actually results in this point where x is negative and y is negative. So something to think about here. Now, let's look at our big angle. Okay? The original angle theta might be something like, I don't know, 240 degrees. If I measured positive 240 degrees, I'd go past 180, and then I'd go 60 degrees past 180 would get me at 240. But that's not the reference triangle. The reference triangle is the triangle that you draw from the terminal side to the x-axis. So notice this triangle right here in red, that's considered my reference triangle. And then I'm going to use this same alpha because I now have a new angle right here. Right? But what that triangle allows us to do is now using this reference angle, I can identify the opposite side, the adjacent side, and the hypotenuse, which means I can evaluate sine, cosine, tangent, cosecant, secant, cotangent, and do any of those because I have a right triangle with the special angle. And I'll put this little highlighter here because that's the same reference angle that we just referred to. But you know what? I could do this. This is a reference angle because it's a nice triangle and it's less than 90 degrees. So anytime you have an acute angle in quadrant 1, it is your reference angle. But anytime you're outside of quadrant 1, you need to find the reference angle. All right, last one, and this could be the trickiest one. What if I have something like 330 degrees? So I'd go all the way around the circle except for 30 degrees, or actually maybe this might be closer to 300 degrees because this looks like about a 60-degree angle. So that would be theta all the way around to the terminal side. But then I need to create my reference triangle. Well, the triangle is from the terminal side to the closest x-axis right here. So see this red triangle? My pen is acting up again. Great. But this angle here, the angle formed between the terminal side and the x-axis, that is what we consider the reference angle. Okay, so that little angle, still our reference angle. But what that allows us to do is now we know here's the opposite side, here's the adjacent side, and here's the hypotenuse. So our job is just to get used to the reference angle, and maybe you want to do one with degrees, one with radians, or maybe two. But what do we want to do? We want to first draw the given angle on the coordinate plane in standard position. So I just got to graph what does 120 look like. And then I want to find and draw the reference triangle and label the reference angle. All right, so why don't you do that first? Go ahead and let's just do the first one here. We always start at 0 degrees. And some students find this helpful, so maybe I'll do this. But if I go halfway around the circle, that's 180. If I go half of that, that's 90. So every quarter rotation is an extra 90 degrees. So then this would be 270. And then 0 and 360, those are coterminal. So we know that our answer of 120 has to lie between 180 and 60. All right, so initial side always starts at 0 degrees, and I'm going to open up. So my angle is 120. Well, 120, if this is 90 and this is 80, 30 degrees past 120, or excuse me, 30 degrees past 90 would put me at 120. But I don't think of it that way. What I want to do is I want to draw the triangle, which is the terminal side straight down to the closest x-axis. There's my reference triangle. And then the angle that we're looking for is alpha. All right, so, well, what is that? How do I find alpha? Well, alpha, what did we do? We went 120, and if I go to 180, if I subtract 180 minus 120, I end up with 60 degrees. Now, hopefully you're thinking, oh, wait a minute. That's a 30, 60, 90 triangle, and I know the side lengths are 1, 2, square root 3, just like the warm-up we did, because that's eventually where we're headed. All right. Degrees are pretty friendly. Radians, not as friendly until you get used to it, and then actually it's actually quite friendly. So I've got 7 pi over 6. Okay. Now, here's the way my brain works. I know that this is 0 degrees. I know it's 90, it's 180. So I'm going to make a connection. Maybe I'll do this in red. I'm going to write these items in terms of radians right now. So this is 0 radians. And we know that pi is the exact same thing as 180, right? So 180 is pi. And then if I cut pi in half, that's considered to be pi over 2, right? But let's think of this fractionally. So I have pi over 2. If I add pi over 2 plus pi over 2, I get 2 pi over 2. But 2 pi over 2, that reduces out, doesn't it? That reduces out to just pi. But I might, for this case, I might just leave it as 2 pi over 2. Because what if I add another pi over 2? That ends up being 3 pi over 2 to get here. And what if I add another pi over 2 to this? That ends up being 4 pi over 2. But wait a minute, isn't 4 pi over 2 just 2 pi? And 2 pi is 360, which is once around the circle. Now, here's something that we want to look at, right? I want to graph a pi over 6. Well, what if I convert all of these to have decimals, or excuse me, denominators of 6? Well, this would be considered 3 pi over 6, right? And then what if I took this one and times it by 3? This would be considered 6 pi over 6s, right? And eventually you're going to do all this in your head, so don't get too confused by it. But what do I want? I want to go one more pi further than 6 pi over 6. So if I go and graph 7 pi over 6, I'm going to go 1 pi over 6 past. All right, now we have to draw the reference triangle. And that reference triangle is from the x-axis closest x-axis and the terminal side. That's a 90-degree angle there. So now I have to figure out, well, what is this angle right here? We call that alpha. Well, if I went to 180, that was 6 pi over 6. How many pi over 6 past 6 pi over 6 did I go to get this? Well, I went 1 pi over 6 past it. So there's my reference angle is pi over 6, which we know pi divided by 6 is 30. So this is like a 30-degree angle. Okay. All right, I don't want you to write this one. Let me just show you this one quick. I'm going to go a little faster so we can get to the final pieces for today. So now I've got pi over 4s. Well, here's what I think of. We know that this was 0. This was pi over 2, right? We saw that before. What if I cut that in half? I cut that in half. This is pi over 4. Pi over 4 is 45 degrees. Now, what if I go 17 of those? Well, here's the way I think of this. 17 pi over 6 is really the same as 16 pi over 4 plus 1 pi over 4. But isn't 16 pi over 4, if I divide those, that gives me 4 pi. And 4 pi is twice around the circle, because once around the circle is 2 pi. So if I go twice around the circle, I'm basically going to go from here to here, and then all the way back again. And then I just have to go the extra pi over 4. So that's just going right back up here to pi over 4. So to draw its triangle, we're going to go here. And then its angle is the reference angle, just this size, not 4 times, not twice around the circle, but that reference angle is just pi over 4. So, we're going to skip that one. I don't want you to write this, I just want you to see it. So this was one of the questions that we would have on Delta Math, and it says, for the rotation, so we know our angle, we have to find the co-terminal angle between 0 and 360, and then we have to determine what it is and what quadrant it's in. So really quick, what would I do? I would take and I would just keep adding 360 until you get your angle where you want it to be. So if I add 360 twice, that's kind of messy, but if I add 360 twice, I'm at 43 degrees. So that's my co-terminal angle. And then you have to decide which angle is 43 degrees in. Well, 43 degrees would be less than 90, which is in quadrant 1. And then the reference angle. Now, in this specific case, the reference angle is the exact same thing as our co-terminal angle. So the reference angle would be 43 degrees. Okay. All right, if you didn't know this, this is another question you're going to have to do, but it's going to say estimate the given rotation. The reason why I put this up here was so you could get another view on how we count the quadrants. Okay. Quadrant 1, 2, 3, and this is Roman numerals for 4. So we have to estimate this rotation. We know it's going to be positive because we're going counterclockwise. And I definitely went from, and this is the way my brain works, 0, that's 90, 180, 270. So I know my answer is going to be halfway between 270 and 360. So if I cut that in half, if I go 30 degrees, I'm at 300. If I go 30 degrees, I'm at 330. So halfway between 300 and 330, my estimation for this angle would be a positive 315 degrees, and they want us to get within 10 degrees of that estimation. Okay? So that one's pretty quick. All right, now, I don't think you need to write this slide because we technically already have it. You guys know what sine is. Sine is opposite over hypotenuse. You know what cosine is, and you know what tangent is, right? SOHCAHTOA. You also know their reciprocals, or if you don't, that's what you're learning, you're getting that to be memorized. But what if I have an angle that goes right here? I can't use this quadrant, I have to use the reference triangle. So this is the importance of where the reference triangle now comes in. And the angle of reference is always going to be right here. Right? So this is how far we move to get to the terminal side, but then our reference triangle is always by the x-axis. And now, because we know what this angle is, we know which side is opposite, adjacent, and hypotenuse, and we also know the sine value. Right? If I move to the left, this is a negative. If I move up, this is a positive. And just so you know, the hypotenuse will always be positive because if I did Pythagorean theorem and I squared these two sides, my answer would always be positive. So this is what you need to use to answer the following problems. All right, I would like you to write these two down. And I'll just share with you. My students in calculus, this is one of the things they struggle with the most. So if you can master it right now, it's really going to help come next year. So we have to determine what is the sine of 330 degrees. Well, the very first thing is this is my angle. Right? So I'm going to graph 330 degrees. I'm going to go all the way around the circle. 330 degrees is everything but 30 degrees. So the closest you can get to estimating, the better. Where would 330 be? It would be about right there. Okay. Now what we're doing though is we're forming our reference triangle. And what you need to know is this angle that's left over. This is your angle of reference, this little 30 degrees. How did I know that this was 30 degrees? Because 330 plus 30 gets me all the way back around to 360. Well, look at what kind of triangle this is. 30, 60, 90. And we know that if I want to evaluate sine of 330, that is equal to the same ratio as the sine of 30. So now, I want to look at sine, which is the opposite over hypotenuse. Remember SOHCAHTOA? And the only thing you have to know is what are those special side lengths for any 30, 60, 90? Well, across from the 30 is 1, across from the 90 is 2, and across from the 60 is square root 3. That's what you need to have memorized. Okay, so some students like to draw it separately. I personally like to draw it in here. Across from the 30 is 1, across from the 90 is 2, and technically that's all we need, right? Even though I know that this is square root 3. But there's one thing that I have to be aware of. See how I went over in the positive direction for my x, and then I went down for my y? That's going to be a negative 1. because we went down to get to this point. Your hypotenuse will always be positive. So what is the ratio of opposite over hypotenuse? It's -1/2, and you're done. Okay. All right, we got one last one I'm going to have you write down with me, and then I got maybe two more I'll show you quickly. So now they're asking for cotangent of 5π/6. So I'm going to graph 5π/6. Now, when I look at this, I think, ooh, isn't that really close to 6π/6? And if it was 6π/6, those sixes would reduce out. So it's really close to being right here at 180. We're just actually 1π/6 short, which might give you an idea of your reference angle. All right, so let's look at what this would be. We're going to start here at our initial side at 0, and I'm going to graph all the way until I get to where 5π/6 would be. This blue angle, it's positive, so we're going in the counterclockwise direction. And I'm going to stop 1π/6 short of reaching halfway across the circle. Well, that 1π/6 is my reference angle. Now, in the way my brain works is pi is 180. 180 divided by 6 is 30 degrees. So if this is the 30, across from the 30 is a 1, just like we saw down here. Across from the 90 is always a 2, and across from what would be the 60 is square root 3. Okay. Now we have to think of something. This is a negative direction, so we're going to the left, which is negative. The x value is going up, so that's positive, and your hypotenuse is always positive. And I didn't label my sides, but if this is my reference angle, which we're always focused on the angle at the origin, that's opposite, adjacent, and hypotenuse. So I just got to think is, what is cotangent? Well, cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. And then there's my answer. Adjacent is negative square root 3. Opposite is positive 1. And we have negative, I don't like how that, we've got negative square root 3 over 1, or because it's over 1, you could just write negative square root 3. Now, we're going to be doing this Thursday, Friday as well. So you're going to get more and more practice with evaluating these functions based off of the reference angles. And the only two things you need to know are 30, 60, 90 and 45, 45, 90 triangles. All right. I've got a couple minutes left. I want to just show you this one really quick. Don't write this. I'm going to go really fast. So here's what I'm thinking. I've got 5π/3. Well, what if it was 6π/3? Isn't that the same as 2π? So if I go all the way around the circle, that's 2π or 6π/3. But I want to be one less than that. I want to go a third pi less than that. So this red angle is 5π/3, but the triangle that I'm going to draw, my reference triangle, is right here, And the angle is what would be left over. I need to go one more pi over 3 to get that all the way around the circle. So this would be a pi over 3. But I know that pi is 180, and 180 divided by 3 is 60. So this angle right here is 60, which means this is 30. And notice, it's the exact same triangle we saw before. Across from the 30 is 1. Across from the 60 is square root 3, and across from the 90 is 2. I went to the right, so it's a positive 1. I went down, so it's a negative square root 3, and the hypotenuse is always positive. And sine is the opposite over hypotenuse. So here's the opposite. There's my hypotenuse. I get negative square root 3 over 2, and we're done. You could do the same thing with your angles. All right. I just wanted to show you this for delta math. What they're going to have you do is they're going to have you move the dot to negative 30 degrees. So you got to move that first. Then you would make up your triangle. And then you could evaluate 1, square root 3, 2, and then you could do tangent, which is opposite over adjacent. Sorry, I'm doing this super quick. But you'd end up with square root 3 over 3. And we've done all that stuff, so you should be okay. All right, homework tonight, 4-3 day 1 on delta math. Submit a screenshot to Schoology. If you have any questions, I'll be available in my office hours from 1 to 2. Please stop by. You can watch this video over again, or I will post the notes as soon as I get, basically right after lunch.